This week we're going to spend all our lectures talking about input and interaction. This is a place where it's very different from what you may have done with programming in sort of the normal imperative mode where you have a sit there at a terminal and you or at your PC and you have a keyboard, and when the time comes you type some input in. We're going to have a lot of differences here because we're going to have input that occurs in multiple ways from multiple devices, and we're going to have to look not only briefly at those devices but also look at them in different ways, both physically and logically. We're eventually going to get to the point where we say we're mostly interested in graphics and event-driven input, and we want to make things smooth, so we'll talk about how input and the display process works within the browser environment, which is another complication for those of you who may have taken the previous OpenGL course where you use C++ desktop OpenGL. It's going to be somewhat, actually very different when we work within a browser kind of environment. So this lecture will talk mostly about the devices, the difference between physical and logical devices and the different input modes, and then in the next lectures we'll talk about how we actually do the programming with WebGL. Now the basis of all of this goes back all the way to 1963, and this was really the seminal event in all of computer graphics, was Ivan Sutherland's PhD thesis at MIT, which goes back now, it's 50 years now that since he did that. But what he saw that they were doing a system that was for radar and applications. So it was an enormous computer, but it had the first sort of interactive display where they had a CRT and a light pen which could actually detect what was going on the screen. And what he realized was the power of the paradigm where the user sees something displayed on the CRT, and then with that device can point to that object as an operation known as picking, and in response to the picking, the user can then enter some information or change the display. For example, if you see an object, you can use the input device to drag that object to a new position. You then see what happens with it, where the object moves or even changes its shape or changes to something else. Then you respond to that. So you now have the user in a loop, and now that's the basic model for all of user interfaces, and that goes back to 1963, and Sutherland and then Sutherland's students became the most creative and important people in computer graphics, and their students became the faculty we now see doing computer graphics. So this paradigm has been the most important event in computer graphics, other than the hardware events, but on the software side this was the key change. Now let's look at input and different ways that we can get input. And what I want to talk about first is the physical devices. So we have devices like a mouse, a keyboard, a touchpad, and we can characterize them by their physical properties, what it takes to generate some sort of information that goes back to the computer. But we can also look at them as logical devices, which we'll explain in a minute, but I think that's actually going to be what you're more familiar about. Now the thing that's probably least familiar is how and when you get that input, whether it occurs sort of asynchronously, it can occur at any time, or it only occurs in response to something you specifically said in your program, like if the following is true, then ask for a number to be entered or something, or a string or something like that. So let's start with the physical devices, and there's a variety of them. There's a mouse, a trackball, and so on. So let me talk a little bit about each one, and let me start with the light pen. The light pen was actually not a device that wrote, it was actually a device that read. And so you had a stylus that had a photodetector in the tip, and so it could see the beam on the CRT. So if you looked at the properties of a CRT, which you talked about a while ago, it actually emits light for a very short amount of time, and it's very bright for an instant, and that's how you set the detector in the light pen, and it detects that. And if you can detect that and the time at which it occurred, then you could figure out what the position is on the screen, because the screen gets redrawn at a very known fixed rate, and so you know the time it started and the time until it got to that position, so you know where it is. So that enables you to do things like not only get a position, but then convert that position into, well, what were you drawing at that time, and so you can get which object you were pointing to. That device is not used anymore at all. I doubt if any of you have seen one, partly because there are better devices and partly because you have different output devices that may not emit light in short little bursts like that would necessary for that to work. So let's go to the trackball and the mouse, which in a lot of ways are the same device, because if you take a trackball and you turn it upside down, you get at least a mechanical mouse where the ball is rolling. But the important things about those devices are that they have two independent degrees in which you can move them, so you get an X and a Y input. And as we'll discuss in a little more in a minute, they're relative positioning devices. You know how you pick up your mouse and you move it to another location. That doesn't change anything. So it's very hard to get an absolute position, like if you're tracing something out, if you're doing some kind of drawing application and you want to get the information from a drawing that somebody gave you by hand. You got to be very, very careful with a device like a mouse or a trackball. On the other hand, a data tablet, which is sort of the predecessor of the touch screens you have now, has usually two-dimensional wires underneath it, and by putting signals down those wires at a known time and looking and measuring with the stylus the voltages or some sort of property that comes out, you can get the absolute location of where that is. So here's an absolute positioning device, and that's become the touchpad that we have now. The technology's changed, but what's stayed the same is wherever you put that stylus gives you an exact position. Joysticks are interesting devices. We don't use them as much as we did, except in special applications like flight simulators. But the important thing about those that I want to keep bringing up is that you build a joystick so it has some resistance in it. There's springs and masses and dampers in there, so that the more you push against it, the harder it is to change the position that it's measuring. A simple joystick is, again, two degrees of freedom. It measures an X and a Y, but it has these forces in it that will tend to restore it back to the zero position if you just let go of it, and none of the other devices have that kind of feel to them. So it's still an important kind of device. Now, what all these devices have in common is not only do they give you some sort of positional information, they also have some sort of buttons or to push that you can use in a number of ways, the most important of which is that they can be a trigger for when you actually return the input from the device to the computer. So for example, with a mouse, we have a button, and when we click that button is when that position actually gets used. Now, there are also a lot more newer devices and multi-dimensional devices. I still have a picture of a spaceball here. Spaceball sort of looked like some sort of a joystick, but it actually was a actually a six-dimensional device. You could push the ball in three independent directions, forward, back, left, right, but you would actually pull and push on it. And then you had three independent twist degrees. It actually had sensors on it, so you can measure the stress or strain on the surface, and so you got three independent degrees of rotation. So that was an important device for example, positioning a camera. We said a camera is a six degree of freedom device, so we can position it with three variables, and then we also have to say what is its orientation, and that's three more variables. So you can do something like tie a spaceball directly to a camera. But the main difference that I want to focus on for a minute here is the difference between these incremental relative devices like the mouse and the trackball and devices like the touchpad, which are absolute positioning devices. And so we have What usually happens also, another point we should make here, is that what a lot of these devices return is not position information, but kind of velocity information. And that's the velocity. If you integrate it, you get position. So for example, if you have so let's look at a joystick. If you push the joystick and look at what's coming out of that as a velocity in the x direction and a velocity in the y direction, and the harder you push it, the further you push it, the greater the velocity is. Then you have a multi-speed device. If you move it a little bit, it's only giving you very small changes when they're integrated, or you integrate slowly, and if you push it all the way towards its limit, it's giving you high velocities in the x and y directions, and then you're getting a much faster change. And that's, you can translate the same thing to mice and trackballs, because you can spin them fast or you can move them very slowly, and that's very helpful in a device. Okay, so let's move away from physical devices to logical devices, and let me go back to a sort of a CC+ thing, because we don't quite have the same equivalent in JavaScript. So let's say you've got a C++ program and you have a line in your code that says cin, the input stream goes into a variable x, or in C you'd have a scanf that says read a value from somewhere and put it in the variable x. What we can't tell just looking at that is what is the device. It may not be a device. It could be, if you're using, you can use chaining the output of one program to the input of the next. You can get the input might be coming from a file, depending on how you're running the program. It might be coming from the keyboard. And one thing is, you don't care. You want to write your program so it's independent of the particular physical characteristics of the device. So this is why we're saying this is a logical device. It's logically providing input in a certain form. If it's a scanf or a cin, then the logical form is that's getting a string back to the program you're running, but that string can come from a file or it can come from typing it in on a keyboard. So we say that these devices can be looked at logically, and that we can let the operating system and the drivers take care of whatever the physical properties of that particular device are. Now, what changes when you get to graphics is that input can occur in a lot of forms. If you're used to just writing Java or C or C++ programs, then generally, if you're interacting with it, you're putting in characters which can represent numbers or strings or perhaps you're getting input from files, and so you have bit-oriented stuff. But it's very, very limited. If you look at what you can do with a mouse or any of the other input devices, you can do much more complex things. And if we define them logically, we can define them in a number of ways. Now, here's an older way of looking at it, and this goes way back to the early standards in computer graphics, GKS and FIGS, and they try to define logical input separately from physical input, and they define 6 classes, which are probably not sufficient now, but it's probably worthwhile to spend a minute looking at them. So what a locator does is returns a position. So something out there gives you an XY or an XY Z position. A pick device returns an object. It says, oh, you were pointing to this square, or you were pointing to this sphere that's on the display. Now notice, here's the difference between the physical device and the logical device, is that you could be using the same physical device in both cases, like for example a mouse, but they're returning 2 different things logically, and we have to decide how we want to use the mouse logically, even though it's the same physical device. A keyboard device is like your physical keyboard. It returns strings of characters, but you can imagine, and I'm sure you've seen, you could put a keyboard up on the display and then use your mouse to decide which keys you want to strike. You do that with your cell phones all the time. So you have the difference between sort of a logical keyboard, which can be all kinds of things, versus a physical keyboard, which is a very specific thing. A stroke device is something you use in drawing. You want to return a whole array of positions. You swipe across the display with your mouse, and you draw some sort of curve, and that curve is defined by a whole bunch of positions that are returned back to the program. Evaluator is like a dial. It's something that returns a single number, or you can talk about ones that return multiple numbers back to the device, but it's sort of the equivalent logically of having some sort of an analog input on your as one of your devices and getting that number, a single number or an array of numbers back. A choice device is like a button. It returns, or a little bit fancier button that can return one of n items. A menu is another example of a choice device. A button might return one of two things, but a choice could return a whole bunch of things from a menu you define. So those are the sort of logical devices. If we look at now at what kind of devices we want to add to that, now most of our systems can handle gestural things. Now that you have really nice touch pads, you can talk about pinching kind of movements. You can talk about two finger kinds of actions, 3-finger kinds of actions, and so they become additional potential logical types you want to consider. Now I want to turn for a minute to this idea of client server. We're going to be talking a lot about that in a little while, but it's important to have that notion because everything we're going to be doing is based on some sort of a client server model. Now, if you look at the diagram, you can say, well, there's a network and there's a bunch of things we're calling servers on there, and they make sense. We understand, like for example, a print server is something that many programs and computers around this network can all use that print server. Likewise, you might have something like a compute server, which would be a big number cruncher that programs could use. Less important now than it used to be, but we used to have a lot of compute servers. File server is very simple. We store our files on another machine somewhere, and that is our server. So in that context, our programs become clients of those servers. Now, how does that convert to graphics? Now, that's may seem a little strange at first, but I think it'll all be okay once you get used to this concept. That a graphics server was something that could provide graphical input and output. So it's a device which has a display on it, obviously, and usually has some sort of a mouse or a trackball, or we'll call that a pointing device, something that can point to a position on the display, and it has a keyboard. So that's generally, at least in the X Windows system, which is sort of the model for pretty much everything we do, whether it's Windows or Macs or whatever. And that's the notion of what a graphics server is. So then are the clients then of that server are our programs. So our program can then use the services of graphics devices, which might be in the same system. If you're running just on your own PC and you've got a screen in front of you and a mouse and keyboard, you're running a program which is a client, but the server is physically in the same place, or it could be somewhere else. Okay, so now let's get to the most interesting part, which are the different modes that we could support. Okay, so if we look at an input device sort of has two basic properties. It has some way of triggering it. So that's generally the button on the device. If it's a stylus, it might be something that pushes down on the tip of the stylus or senses something. But if it's a keyboard, it's the pressing of the key or the releasing of the key. Are triggers of the device. Now, when the device is triggered, we said that they're going to return something back to the computer. Well, that is going to depend, it's called their measure, that's going to depend on the particular device and its capability. If it's a mouse or a trackball or a trackpad or a touchpad, it's going to generally return the position. It might also return some other information as part of the measure, but its most important thing is it returns position. And if it's a keyboard, then it returns the code of the key that's pressed and perhaps some other information. Now, for example, a mouse might also return, well, which button you were triggering it with would be a typical thing that it would return. Now, the simplest form of input in the simplest mode is called request mode, and that's probably what you're all familiar with when you run a program and the program sits there and asks you for some sort of input. Now, if you think about that in terms of what you might enter when you see a prompt on the screen, the program is actually sort of in a halt state. Nothing is happening with the program until you enter that information. And while you're entering that information, you can backspace, you can do things. But not until you hit that enter or return key does anything actually happen. So nothing is being returned back to the program until the device has been triggered. So we can look at it in this simple diagram, is that there's some sort of measurement process that's going on. That might be going on constantly, that the operating system is constantly looking at the keyboard and it's looking at the other devices attached. But from the program point of view, what you're saying is, oh, do a scanf. Well, that's a request to this process, and it's triggered, as we said, by the return key, and then the measure comes back to the program. So this is, characterized by having, full control over when things happen, and it's also characterized by you're specifying in your program what the logical device is. So the program is really what's in charge. Now contrast that to event mode, and in event mode, there's again a trigger process going on, and there's a measure process going on, but the devices, you may have multiple devices. So the way I probably should have drawn that is with multiple devices, all having some sort of measure process going on. And whenever any of those devices is triggered, they can happen at any time, which is very, very different from request mode. That measure goes into what's called an event queue. And so things could be happening in the system, whether they're mouse, keyboard, other devices on the device, other programs running. They're all generating input potentially that goes into this queue. Now, what does it look like from the application programmer's point of view? The program could be sitting there waiting for events to happen, and or it can be just examining that queue periodically or whenever, in a variety of ways. But all kinds of things are going in, not under the control of the program. What the program controls is what it does with those events. It could discard events, it could respond to certain events, and that's going to be what's at your control, is looking at this queue and deciding what to do. Now, this is not quite the model we'll be using as a programming model with WebGL, but it's really close to what's actually going on within the system. Now, so the other thing we want to look at is, well, what kind of events are you really talking about here, which are relevant to computer graphics? So let's finish up by looking at the types. So the simplest ones or at least the ones you're most familiar with, are things like the mouse. You click one or more buttons, they generate an event, and that input is going into some event queue. You may want to have other things that your mouse could do. So you may be measuring the motion of the mouse all the time. So that's the idea, that this measure process could be going on all the time within the operating system and the browser, and you don't actually see it until you need it, but it's happening. And so just moving the mouse without clicking any buttons is another type of event, which is called a motion event. Obviously, you have keyboard events. You can distinguish between pressing a key and releasing a key. They're distinct events in most systems. Then you have other events which are not just dependent on the physical devices being triggered, but depend on interacting with the screen. A lot of those are called window events. So for example, as you're working in this complex environment with a lot of windows up, some that may be graphics and others aren't, you're used to things like, for example, iconifying the window. You click on a little circle or something up in a corner, and that window becomes an icon that you see. Or you click on the icon and the window comes back. Well, all kinds of things happen there. Different things are exposed. Things that were behind that window you can now see when you iconify it. How do those happen? Well, those are events. They're examples of window events. Also, taking a corner of a window and pulling it with your mouse, dragging it to a new position so you get a different size window. That's a complex thing we'll be talking about later this week, because you have to decide, what do you do with the things that were being redisplayed? They're now in a smaller window. Do we eliminate some things that don't fit, or do we shrink everything down to fit in a smaller window? That's something that's going to be up to you, but it's in response to this window event happening. And in some OpenGL implementations, for example, what we did with the GLUT interface in the old desktop OpenGL, we talked about the non-event, the idle event. What do you do if nothing's happening? So suppose you're looking at this queue and nothing's going on. What do you do? So for example, something like a screensaver. A screensaver is kind of an idle response to no events actually happening. So in the next lectures, we're going to look more specifically at what happens within the browser, what's the execution environment in the browser, and then how do we integrate that with what we do with WebGL.